Hello, my name is Vansh and today through this video I am going to demonstrate what is QUIC. So basically QUIC is an UDP based internet connection protocol which operates at the transport layer. So according to the Internet Engineering Task Force, it is the protocol which operates on the transport layer, and this layer is the layer number 2 in the TCP IP model stack. And also in 2012, all the Google engineer developed the QUIC UDP internet connection protocol due to an experiment for the performance of the web application. And in one word, the motivation behind the development of QUIC, I can say, is the speed. Because the reason being, we are using the TCP connection for the reliable connection, and which is slow due to the handshaking process. But in the further slide, we can see how it reduced that. So in this, you can see HTTP request with the transport layer protocol TCP and HTTP request with the transport layer protocol QUIC. In this, you can see it taking multiple handshaking for establish a connection before sending data. But in case of QUIC, it very different. It make only single round trip connection, round trip time, which and also if it make prior connection to that server, then in the future it do not make that connection and take from the cache. And you can see it taking 200 millisecond for the connection and 300 for the data, but it taking 0 for the connection and 100 for the data. That's why QUIC is very fast. So first now understand why we need it, why we need QUIC. So as all of us using the internet and watching the movies, using the emails and sending the messages, playing games, all things are working on internet, and everyone forced need fast speed of the internet and the enhancement in the performance. So to reduce the connection establishment time and loading the page faster, improving the user experience. Second one is to reduce the latency, as it provides the multi-stream and multiplexing and reduce the head of line blocking so that all the package can transfer, and if any packet get corrupted so that it don't block the stream and the other packet can go through the other stream. So it reduce latency in that way. Also, it improve reliability because it is built on the UDP, and UDP doesn't make any connection and it is unreliable. But it make an prior connection, that is one RTT connection, one round trip time connection. And that connection support by default encryption, error correction, and many other algorithm for correction in the error, and so that it helps in to improve the reliability. Also, as it support by default encryption using the TLS version 1.3, so that it may ensure the integrity of the data during the transmission. So let's come on the functionality of the QUIC. First one is the multiplexing. Multiplexing is like sending the data over the multiple stream, and if the packet is lost in one stream, so that it doesn't block all the packet can move smoothly from the different streams. And second one is the improved handshake performance. As you can see, it's only making the one round trip time handshake, and in that it's exchanging, sending the client hello and receiving the server hello, and in that it exchanging the cryptographic algorithm and the TLS versions and the cipher suits, all the things. And that thing I am going to show in the last in the Wireshark, how it share and what are the fields and what are the data it share. Third one is the security, as it's support by default encryption, so it has very good security and maintain the integrity of the data. Fourth one is the congestion control. So it has many congestion control algorithm and processes, and also it support multiplexing, so it control the congestion by that way. Now coming on the frame in QUIC, so there are two type of frame mainly, special frame and regular frame. Special frame is like which encodes both the frame type and its corresponding flag. Like stream, it tells whether to start the stream or stream the data or not. Acknowledge field to acknowledge some stream data or any data. And then congestion feedback to give the feedback to, like if the packets are transferring slow, then it gives feedback to improve the speed of the sending of the packet. And if the packet are transferred very high speed and there is a congestion at the receiver side, so this feedback will tell to lower the speed. And regular frame like padding is like help to increase or decrease the maximum window size of the receiving or the sender. Reset stream tell whether to reset the stream in which it's sending the data. Connection close the connection after sending the whole packets and data. Go away field to go away from that. And the window update field basically update the window whenever there is the requirement of the padding. Using the padding, update the window. And block field tell whether some packet is blocked or not, some stream is blocked. Stop waiting tell whether to stop. And ping is used for checking the connection. So let's come on the advantage of QUIC. First one is the multiplexing without bottleneck. As it's for multiple stream, you can see in TCP there is only one stream, and if packet number 4 is blocked, it can block all the packet 5, 6, 7, 8 till the time fourth is not retransmitted. But in case of you QUIC with UDP, it is very different. It allow multiple stream, and if the packet number 5 is blocked, it can only block the packet number 6 until it retransmit, and all the other packets can travel smoothly. Second one is the reduced latency, as it independent stream handling and use UDP to facilitate faster data transmission and avoiding the retransmitting the lost packet across all the stream. Only in that stream the packet is corrupted sent. And so in that way it will reduce the latency and make the user experience better by making the loading web pages faster. Next one is the connection migration support. So connection migration support is like we are connected any website, web app, or anything. So if we change our network, like initially we are connected to the Wi-Fi, then we change to home network, like my mobile network to, and I go outside of my home, then I switch to mobile network. In that case, it doesn't reload the page because the connection is not dependent on the IP address. It dependent on the QUIC address, generated QUIC address, which I can show you in the Wireshark in the demonstration. So that address is used ID, basically the ID which is made for this connection. So it helps to make a smooth connection and doesn't disrupt the user on changing the network connection. Fourth one is the by default encryption using the TLS version 1.3. So now moving to the disadvantages of QUIC. So here we are. Yeah. So before the disadvantage, I want to show the experiment which I have done. So this is the QUIC protocol. Using the QUIC protocol, I am requesting the google.com, and using the TCP protocol, I am requesting the google.com. You can also perform the similar experiment by using the Chrome flags and making the by default flag for that QUIC to the HTTP2 and disabling the QUIC flag in that. So in QUIC, you can see it taking 486 millisecond, and in TCP, it taking 875 millisecond, which is almost double. So you can see how less time QUIC take. Now coming on the disadvantages of QUIC over TCP, as QUIC is a new protocol, so all not the browser support it yet, so it can lead to compatibility issue. Also, this protocol is not based on the traditional TCP, so it may not support all the debugging tool that will make a challenge for the network administrator for debugging purpose. Also, its congestion control mechanism is very different from the TCP, so it's so different behavior in different term of congestion. Now coming on the network application that uses QUIC. So as Google developed it first, so all the Google application nowadays uses QUIC. Google Chrome to deliver all the web pages very smoothly and fastly uses the QUIC protocol in the HTTP3. Also, YouTube to deliver the video content to the user very smoothly, fastly, and efficiently, and reducing the buffer time and optimizing the video quality. So it's also using YouTube in that way. In the Google, other services like Gmail, Drive, and many more. So in that case, it is also using Quick for faster and reliable data transfer. So this is the graph you can see. This is till the date 8 March 2024. And this graph shows the usage of Quick for website in the percentage. So you can see on 1 April of 2023, almost 9% websites are using Quick, but there is a sudden decrease till 1 June, and which reached to almost 7.3%. And then it very slowly increased until 1 March or the 8 March, 7.9% or 7 point approx 8%, 7.8% websites are using Quick. And I get it from the w3text.com. So now coming on the security threats in the Quick protocol, as everything process possess security threats. So now discuss the security threats of the Quick. First one is the denial of service attack. So this is an attack which is like make the denial of the service for the authorized user. So attacker may try to flood the server with the multiple quick connection and request or manipulate the packets so that it exhausts the resources of the server and the authorized user can't access that service. So it means denial of service attack. Second one is the packet manipulation attack. In this, the attacker tried to manipulate the packet, inject malicious payloads, and tamper the encryption which is present in the packet and make the packet corrupted. Third one is the side channel attack. This attack is based on the timer or on the cache, and it will like target all the cryptographic algorithm used in the security of the TLS, and it leaks the sensitive information or compromise the security. Last one is the endpoint spoofing. If the attacker may get the endpoint, it spoofs that and manipulate the communication between the client and the server, and which can lead to various security risks like the man-in-middle hijacking or session hijacking. Now let's coming on the scalability of the Quick. So as it was multiplexing, so it reduced the head of line blocking also and allow the resource utilization and reduce the overhead associated with establishing multiple connection. The second one is the adaptive congestion control. At as it uses dynamically adjustable congestion control algorithm. So according to the network condition, it will efficiently adjust and utilize the available bandwidth and adapt to the network changing conditions or environment. Third one is the recovery of the packet loss. So it include an very good mechanism for packet loss recovery, like only this selective acknowledgement, like only retransmitting or getting those packets which are actually corrupted, not all the packet in that stream. So it helps to reduce the latency also. Fourth one is the head of line blocking, which is reduced using the multiplexing. Like if any packet is corrupted, so it doesn't block all the stream packets, it only block that stream packet only in the same quest. Also, it's support for load balancing, like Quick nature make it easier to distribute traffic across the multiple servers on the virtual machines of the data centers. And it facilitated effective load balancing and scalability in the distributed environment. So now coming on the demonstration of the Wireshark. So this is the packet which I have recorded for the Quick. And first one is the client hello, as I shown you in the diagram of the Quick handshaking. So let us see what is in the Quick hello. So here it is using the UDP protocol in the transport because it is built on top of that. So here is the Quick IETF. Here is its version, which is draft 29. That is it drafted 29 version of the Quick of the HTTP 3. And here is that connection ID which I am talking about in the connection. Like it doesn't depend on the internet IP connection. It make its own connection ID. And if you are continuously changing your internet, switching your internet from home to personal, then it doesn't disrupt you. And this is that ID. Now coming on the crypto inside this, it using TLS version 1.3 to by default encrypt the packets. And here is the application layer protocol. Let's see what is inside this Alpine protocol. Yeah, it's HTTP 3 version 29, and all the HTTP 3 protocol nowadays use QUIC protocol in the transport layer. And this is for basically the youtube.com. I have recorded these packets of the youtube.com. Here is telling the name of the server, that is the youtube.com. And cipher source is the cryptographic algorithm which is sent to the server and exchange with the server. Now let's see what is in the server hello. And you can see the server hello protocol message. And similarly, here is the connection ID, which is similar to that to make a connection. And here is also using the same TLS version, and here is the server hello sending. And inside this, it's not showing the application. And in the cipher short, it's also telling its cryptographic algorithms. And also it's using the UDP because QUIC is based on that. So server hello is like similar to that. So that's all in the Wireshark demonstration. And now it's over. Thanks for watching.